Algebra 2. Today we're going to look at how to solve quadratic equations with a third method called completing the square, and we're also going to be looking at how to do this with square roots. So up to this point in this unit, you know how to solve a quadratic equation for x by either factoring, if it factors, or by using quadratic formula. And keep in mind the quadratic formula works no matter what type of quadratic equation you have. This method you need to use in a certain situation. So we're going to start with solving by square roots. Quadratic equations in the form ax squared equals c can be solved by taking the square root of both sides. Please notice that this form is missing the linear term. It's missing the bx. So if you have an x squared term, and you have to if it's a quadratic equation, and you may have a coefficient in front of it, of course, but if you see a number, like a constant without a variable, and that's the only two terms in the equation, then this method is a good one to use. It's a very easy method. Example 1, x to the second is equal to 121. Notice this is the quadratic term, and this is the constant term. In the past, we've been doing ax squared plus bx plus c equals 0. Well, with this method, the square root method, you don't want your equation necessarily to equal 0. You want it to look like this form here that I've circled. So if it's in this form, then all you have to do is do the opposite of squaring, which is taking the square root. You're trying to undo what's done to the variable. Remember, the whole goal here is to solve for x. Whatever you do to one side of the equation, you must do to the other. So you're going to also put a square root on the second side. Underneath the square root of x squared, these two symbols in mathematics are or is an inverse operation, meaning like opposites, so they undo each other. That means that you're left with only the variable x equals, and then anytime you have an equation, listen closely, anytime you have an equation and you're taking the square root of both sides, there's actually two possible answers. If you were to type this into your calculator right now, the calculator would only show you one answer. It would give you 11, because 11 times 11 is 121. However, the calculator only gives you what's called the principal answer. There are actually two solutions to this problem. Keep in mind, when you're doing square roots, you're trying to, in an equation, you're trying to give all answers possible. And so, since a negative 11 times negative 11 is also a positive 121, then that's the reason that this problem, and problems of this nature, have two solutions. Remember from the past, I've made this comment before, but it's important to repeat it. When it's a quadratic equation and you have a power of 2, that means you can have two answers. Positive, negative 11. Okay, let's move to number 2 example. In number 2, I see 4y to the second is equal to 64. Again, pointing out hopefully obvious things. This is the quadratic term. This is the constant term. I'm missing the linear term, so that means the square root method is a good method to use to solve for y. However, look at example 1 again compared to number 2. Number 2 has a coefficient other than 1. The a is 4. And so anytime you're solving a quadratic equation using a square root method, it's always best to get the variable by itself first before you do the square root. So you're going to notice that 4 is being multiplied by y squared. You're going to do the opposite of multiply, so you're going to have to show this step first. Please keep this in mind because this is a common mistake. I've had a lot of students in the past not do that, and then they miss the answer. So always isolate or get the variable quadratic term by itself first. 64 divided by 4 is 16. And then you're going to undo the power of 2. Again, the opposite of squaring is taking the square root. Whatever you do to the left side, you have to do to the right side of the equation. The square root of y squared just becomes the variable, so we drop the y down. And again, same thing I said over here, because it's a quadratic, there's actually two answers. the square root of 16 on a calculator is 4. But negative 4 times negative 4 is also 16. And so we're going to go ahead and put our little double sign, and there are my two answers. Again, it's an easy process, but you can only solve by square roots when the problems are in this form. Number 3, 4x squared plus 10 equals 46. I notice I have a quadratic term, and I actually have two constants in this problem. I do not have an x. And so the next thing I need to do is put my constants together. I'm going to transpose in the next step. So it's going to be 4x to the second is equal to 46 minus 10. Next step would be 4x to the second is equal to 36 when I subtract those. And then I'm noticing x is not by itself. There is a 4 being multiplied by it. So I'm going to have to show division, similar to number 2 example. Now I'm left with x to the second is equal to 36 divided by 4, which is 9. Solving for x, I have to undo the square, so I take the square root of both sides. You're going to drop down your x equal, and the square root of 9 is a positive 3 and also a negative 3. Okay, and that's the amount of steps that you need to show, and please make sure you show all your work. Okay. Alright, so in the title, in today's learning target is the same as the title. It's solving quadratic equations by square roots. We have just looked at a few examples of that nature, and now the second piece to this learning target is what do we do when we're completing the square. Okay, next we're going to solve quadratic equations by completing the square. In order to do that, you're going to have to follow the following steps. It's a process that you're going to do to take a quadratic equation and change the way it looks. Alright, step 1, you're going to get all variable terms on one side, and you're going to get the constant on the other. Get all variable terms on one side and move the constant to the other. And so we also want to make sure that the coefficient of the quadratic term is 1. Now this is different from all the other methods. In factoring, in quadratic formula, and the ones from the past, we always wanted the equations to equal 0. With this section, you are supposed to make sure that the constant, the number without the variable, is behind the equal sign. Kind of pointing that out one more time. Okay, step 2, you're going to take 1/2 the b term. And so whatever this number is in front of x, you're going to take half of it, which is essentially the same thing as dividing by 2. So you're going to take half the b term. You can do that part in your head. Then you're going to square that answer. Whatever number you got, you're going to square it. You're then going to put it in a new c position, and I will explain that in a few minutes with an example. And these steps will make a lot more sense when you're seeing it in action. Again, you're taking half the b term. Please make sure you're writing everything down, and you're squaring it. You're then putting that number in the new c position, and then you're going to add the same number to the other side of the equation. So whatever you add to the left side of the equation, you've got to do the same thing to the right side to keep the equation balanced and keep it the same. After you do this two-step process, you've now created a problem that looks different. It's actually the same, but it looks different. You're going to create a problem on the left in front of the equal sign that's a new trinomial. That new trinomial should factor now, so you're going to factor it using a process from the past. It could be a GCF, trinomial method, something like that. And then once you factor, you're going to solve step 4. Solve the remaining equation by taking square roots. And then number 5, you're going to solve the equation for x. Okay, this process is called completing the square. And we use this process when we notice that the original problem does not factor for us. This is like a different way to do a problem and still find the answer, again, when the equation does not factor from the beginning. Alright, so if we got all 5 steps written down, ready to go, we're going to, and I'll refer back to these, we're going to make sure we understand each piece. Okay, example 1. And I'm going to type up here, solve by completing the square. Number 1, x to the second plus 6x minus 3 is equal to 0. Again, first of all, make sure you always check to see if there's a quadratic term in the problem. There has to be a power of 2 on one of the terms, or none of these methods that we've been learning is going to work. So factoring, quadratic formula, computing the square, all that must have a power of 2 in the problem on the solving part. I'm going to scroll back to the last slide. Number 1, step 1, get all variable terms on one side of the equation, and please move the constant to the other. So in this question, that means for me to take the negative 3, in the next step, show that I've transposed it. So it's going to be x to the second plus 6x, and then I need you in your notes to leave a little space right here. You scoot your equal sign out, and then negative 3 comes across as a positive 3. 0 plus 3 is just 3, so I'm just going to leave off my 0. Okay, so I've done step 1. Also, I need to make sure the coefficient of the quadratic term is 1. When it's not, you have to actually divide through by that number, and we will see that later. Okay, so in this case, I have a 1 here. I'm good to go. Going back to the previous slide, step 2, you are now supposed to take half the b term and square it. Half the b term. So in this problem, my b term is 6. Okay, now it's actually a positive 6, but if you don't necessarily have to worry about the sign. Just pick up the number, and in your head, either do 6 times 1/2, or it's essentially the same as 6 divided by 2, which I think is easier. So 6 divided by 2 is 3. And then according to your steps, it says after you take half the b term, you square that new number. Okay, so let's go back. 6 divided by 2 is 3. 3 squared. 3 raised to the second power is 3 times 3, which is 9. Now, what do I do with that 9? Well, according to your notes, you're going to put it in the new C position. The new C position is this position, this little space that I had you leave on your paper. And so you're going to put positive 9 there. Again, 6 divided by 2 is 3. 3 squared is a positive 9. Right now, I'm going to pause for a second. Right now, I have changed this problem. I have added 9 to this equation. So as of right in this second or in this moment, this problem is not the same. So in order for me to keep it the same, I then have to add the same number to the other side of the equation. So if I add 9 to the left, I have to come over here and add 9 to the right. Again, I'm trying to keep the equation balanced. Okay, so next step, you would, I'm going to come over here and just go ahead and add 3 plus 9, make it 12. And copy everything else down over here. Since the left side, I don't see any like terms. And then we'll take a look at our steps for completing the square to see where we are. We've done number 1. We have completed step 2. Step 3 says factor the new trinomial. Okay, so we can come over here. Here's my new trinomial. and they want me to factor it. Alright, so I'm going to drop my equal 12 down, kind of keep that organized. Come over here, I do not see a GCF in any of these terms. Obviously it's 3-term problem, so it looks like a trinomial, and my goal is to see if it factors. Factors of x squared are x times x. Factors of 9, remember in the past we've drawn like a little factor tree, 1 and a 9, and factors of 9 are just 1 times 9 and 3 times 3. And so I need a 6 in the middle, so I'm going to definitely choose the 3's. Then I'm going to take a look at the sign. The last sign is a positive, meaning the signs are in the answer should be the same, and you're going to pick up that plus sign because it's in the middle. Okay. Alright, then I'm going to scroll back. I have factored, check off step 3. Number 4, solve the remaining equation by taking square roots. Okay, so let's see how that works. Solve the remaining equation by taking square roots. What you have to notice is after you factor it, and this process will be the same in every problem. Okay, if you follow my steps, you're going to kind of repeat the same things. But you notice that this is exactly the same as this. These binomials are the same. So one shortcut in math is when we have 2 factors that are the same, we can actually just write it down one time and put a big power of 2 on it. Like 5 times 5 is the same thing as 5 squared. Well, x plus 3 times x plus 3 is the same thing as x plus 3 quantity squared. So that should be your next step in your process when you're on your own. And then my step from my notes said to now solve the equation by taking the square root. I want you to notice that the x and the 3 are both in parentheses, so we can't like separate those right now. In order to get to solve for x, because that's our goal, we have to get rid of this big power of 2. For the 3rd time, again, the opposite of squaring anything is taking the square root. So you'll have to put a square root on both sides. Now what's going to happen in this type scenario is this binomial, this x plus 3, is going to come outside the radical. So that's what's going to be left. Square root of something squared is all of that something back. The square root of something squared is that something back. And then, again, I've repeated the same concept. When you're doing a square root of an equation, please remember there are 2 answers. So you need to put your little plus minus there. And then you can use a calculator and type in the square root of 12. We'll just do it that way and give a decimal answer here. I'm going to keep rounding to the nearest hundredth. So on my screen, I have this big messy decimal, but I'm going to write 3.46, it looks like. And then, again, my whole goal is to get x by itself. I've got a little bit more work to go. I've got to take this plus 3 now and transpose it. But please notice that there is actually 2 things going on here. So this might be a good time to go ahead and write down both equations so you don't miss your answers. So one of the equations is x plus 3 is equal to positive 3.46. The second scenario is x plus 3 is equal to the negative 3.46. And so that is going to make a big difference. You're going to, in this problem, of course, just transpose. So now you're looking at x is equal to 3.46 minus 3. Okay, well that is going to be x is equal to 3.46 minus 3 is just a positive 0.46. Alright, so that's your first solution to this problem. Okay, second equation you solve by transposing. Okay, when you do that, you get x is equal to, and that's going to be a negative 6.46. And so I have, notice the big difference in these answers. I have two answers, two solutions to this problem. Also notice they're decimals. And remember, I rounded this, so they're kind of messy decimals. So that means up front that this problem right here, which was the original problem, I could have tried all day long and I never got it to factor. So that's why we had to use a different process. We had to complete the square, kind of manipulate or change the way the equation looked by following the completing the square steps. And once we did, then we found why it didn't factor, because our answers are messy decimals. All right, let's try one more. We'll just do this one. Number 2, 3x squared minus 12x plus 6 equals 0. It is quadratic. I see 3 terms. The directions tell me I have to practice completing the square, so the first step is to transpose the constant. So I'm going to be, in first step, have 3x squared minus 12x, space here, and then equals, and then negative 6. Okay, after I get all the variable terms on one side and the constant on the other, I have to make sure the coefficient of the quadratic term is 1. Well, unfortunately in this problem, it's not. And so over here, I kind of skipped that and kept going. But when it's something other than 1, this is what you'll need to do in your practice set. Whatever that number is, you're going to have to factor it out. That's a GCF. Pull it out from those terms. 3 times something is 3x squared. That's just going to be 1x squared. 3 times something is negative 12x, and that's just going to be a negative 4x. And then again, remember to leave this space empty, because that's where your other number is going to go. All right, completing the square steps. 2, take half the b term and square it, and then put it in the new c position. Take half the b term, square it, and put it in the new c position. All right, in this problem, it's a little different from the last one. Remember, I had to factor out this 3. Well, right now, for the rest of these steps, I'm going to almost like ignore the 3, and your eyes are only focused on this quadratic term and this linear term. And the b is what I've highlighted right now on your screen. The b is 4. It's actually negative 4, but remind you what I said over here, don't worry so much about the sign, because it will take care of itself. Your job is to get the b, take half of it, or just divide it by 2. So 4 divided by 2 is 2. Take your answer in your head, square it. 2 times 2 is 4. You're going to put a positive 4 right there. And it will be positive because, and let me go ahead and use the negative, just in case you're wondering why we leave it out. If I did use negative 4 divided by 2 is negative 2. When I square negative 2, just kind of visualize this in your head, negative 2 times negative 2 is still going to give me a positive 4. So we're good either way. All right, next step, you're going to keep dropping that 3 down. Okay, just don't forget it, but you're not really using it right now. And then your focus should be on this new trinomial you created. It should factor now that we've followed a couple of the completing the square steps. That's what completing the square does. It takes a problem at the beginning that's not necessarily factorable, and it manipulates it or changes it so that when we do go through the steps, the new trinomial will factor. Again, factors of x to the second are 1x and 1x. Factors of 4 are 1 times 4 and 2 times 2, but we need a negative 4 in the middle, so I'm going to stick with the 2's. Notice again your slash sign of your trinomial is positive, meaning these signs have to be exactly the same. You know what to use by looking at your middle sign, and it's a negative, so I'm going to drop 2 negatives down. Next step, please notice the binomials in parentheses match exactly, so we'll use a little shortcut. we'll write x minus 2 quantity squared, and then drop the negative 6. Okay, again, keep your eyes on the variable. Our goal for this entire problem is to figure out a way to get this x by itself so we know what the solutions are to this quadratic equation. However, we can't solve for x until we get rid of this 3, and this 3 is actually outside parentheses, so we know that means multiplication. We also have to get rid of the power of 2, and then later on we have to get rid of the negative 2. So there's like 3 things that we have to kind of jump through, hurdles to get across before we can get x by itself. Please always do what is farthest away from the variable, and in this case it's the 3. We didn't have to do that over here, okay, obviously because that was a 1. But this is 3, and in order to get rid of it, you're going to do the opposite of multiply, so you're going to show division. Okay, your 3 is going to cancel. You're going to be left with x minus 2 quantity squared, and that's equal to negative 6 divided by 3, which is negative 2. So, try that again. So it's x minus 2 quantity squared equals, and then negative 6 divided by 3 is negative 2. Oh, alright, time out. Let me backtrack because I made a mistake and I'm glad I caught it just now. So let me backtrack. Okay, before I erase anything, when I took half this negative 4 and I squared it, I put 4 here. Okay, what I was supposed to do is, remember, add to the other side to keep it balanced, and I did not do that. So we're going to backtrack, and I apologize because you're going to need to erase. Well, I'll do it together here. Let's erase from there down. I'm glad I caught it right now, though. Alright. Sorry about that. Okay, let's try this again. So we factored out the 3, and now I figured out what to go there. Okay, so right here, I didn't add to the other side. So I was solving a problem, but it wasn't the exact same one, unfortunately. Alright, now here's how we handle this. Over here, it was add 9 here, and we're good to go. But please be careful, because, let me grab a highlighter, you have actually not just added in a positive 4. Because of the position of it, where I put it inside parentheses, you've added in 4 times 3, which is 12. So we're going to need to, we got to add 12, we're going to need to add 12 to the other side. And let me say that again, because when you have a coefficient other than 1 and you have to factor it out, this step right here is extremely important that you don't forget, because it will obviously change the entire problem. But when there's a number on the outside and you go through the process and take half the b term and square it and put it here, please don't just look at that number and add it over here. Remember, it's inside parentheses, and it's got to be multiplied by that GCF, and whatever that product is, that answer, that's what you have to add to the other side. Alright, let's try this again. We're going to drop our 3 down. Here's our trinomial. We're going to factor this one. Hopefully I got it right this time. And then we are going to keep rolling here. X squared factors are x times x. Factors of 4 are 1 and 4 are 2, 2. I'm going to use my 2's. Same sign, and they need to be a negative 4, so we need 2 negatives. Then over here, I've got negative 6 plus 12. Negative 6 plus 12 is a positive 6. Okay, just like I had a second ago, we're now going to notice these are the same. We're going to do the shortcut and write it down as 1 binomial quantity squared. And that looks a lot better than what I had. Alright, same deal, same procedure. I'm solving for x. I've got to get rid of the 3. It's being multiplied, so I have to divide. Now I'm left with quantity x minus 2 squared equals, and then 6 divided by 3 is 2. There we go. Alright, again, solving for x. I have a big power of 2, so I'm going to do the square root on both sides. I'm going to be left with just the binomial, x minus 2. I just took the square root of both sides of an equation, so there's two answers, positive, negative. And then you can use your calculator and just type in the square root of 2. It is a messy decimal, but we're going to round to the nearest hundredth, so we're going to just say 1.41. Alright, next you're going to set up your two problems, and that way you can solve for x. Alright, so we're going to transpose. The first problem is x minus 2 equals positive 1.41. When I add 2 to 1.41, it is going to be 3.41. That's one of your solutions. Over here, when I transpose, x can be found by doing a negative 1.41 plus 2. Okay, so negative 1.41 plus 2 is going to be a point. There we go, 0.59. And there are my two solutions for this problem. I got it. Okay, so again, you're going to use your notes, use all these steps exactly as I typed them out, okay, and hopefully modeled to you well enough for you to try. And just make sure you be really careful on problems like this. When you add in that number, please don't forget to multiply it by the outside and then add it to the other. Okay, so we'll give this a try and see how we do.